Something strange happened to the human face about 2 million years ago. The jaw shrank, the brow flattened, the features softened into something almost childlike, and nobody was forcing it to happen. There was no predator making faces gentler. There was no tool requiring it. Something else was doing the selecting, one mating decision at a time, for 2 million years straight. For most of human history, attraction wasn't a matter of taste. It was a filtering system, a set of instincts built to solve one problem. Who, out of every possible mate in a small and dangerous world, was safe to bet a lifetime on? And the traces of that filtering system are still visible today, carved into modern faces, modern bodies, and modern desires. Even though almost nobody knows they're reading an instruction manual written by ice ages, parasites, and starvation. This is the story of how the human face and body became a kind of resume, written in bone, skin, and proportion, read unconsciously by every human who ever lived, long before anyone had a word for beautiful. Chapter 1. The Softening in 2014. A research team led by Robert Cieri at Duke University did something almost nobody had tried before. They measured the skulls of over 1,400 humans, some barely 80,000 years old, some carved out of the last century, and laid the measurements side by side. What they found reshaped the entire conversation around what attractive even meant to the earliest members of the species. The oldest skulls in the study were heavy-browed and long-faced, with a jutting ridge above the eyes that gave the whole face a permanently intense, almost aggressive cast. But somewhere between 80,000 and 10,000 years ago, that heaviness started disappearing. The brow ridge flattened, the upper face got shorter, the whole skull, across generations, drifted towards something rounder, softer, and by modern standards, more approachable. Cieri's team called it craniofacial feminization, and the cause, they argued, traced back to a single hormone, testosterone. Lower average circulating testosterone doesn't just change behavior, it reshapes bone. It softens the exact features that testosterone builds up during puberty, the heavy brow, the long jaw, the pronounced cheekbones. So a population-wide drop in testosterone would leave exactly the fossil signature Cieri's team found, faces getting gentler across tens of thousands of years without a single individual choosing it. Here's where it gets interesting. Testosterone doesn't just shape bone, it shapes temperament. High testosterone in males tends to correlate with more aggression, more dominance seeking, more willingness to escalate conflict. So a population trending toward lower testosterone is also, statistically, a population trending toward less aggressive, more socially tolerant males. Which raises an uncomfortable question: why would evolution favor that? The leading answer comes from an unlikely source: foxes. In a decades-long Soviet-era breeding experiment, researchers selected silver foxes for exactly one trait: tameness around humans. Nothing else. No selection for appearance, no selection for size, just calmness. And generation after generation, something unplanned happened. The tame foxes developed floppier ears, curlier tails, and, most relevant here, softer, more juvenile faces. Domestication, it turned out, doesn't just change behavior. Selecting for calm temperament seems to physically remodel the skull as a side effect. Researchers now call this general pattern domestication syndrome. And a growing number of anthropologists, including Brian Hare at Duke, who worked alongside Cieri, argue that something similar happened to humans. Not tamed by an outside force, but self-domesticated, a species that began selecting its own mates for lower aggression and higher social tolerance, and got softer faces as a side effect of that choice, generation after generation, for tens of thousands of years. So the earliest, deepest layer of human attraction wasn't about symmetry or color or any single feature at all. It was a filter for temperament, dressed up as bone structure. A gentler face wasn't just easier to look at. It was a signal. It said, this person is safe to build a life next to. Person will cooperate instead of dominate. And for a species that was starting to live in larger, denser, more socially complicated groups, that signal might have mattered more than almost anything else on the list. But temperament wasn't the only thing the ancient eye was scanning for. There was a second signal, one written not in the shape of the skull, but in its precision. And it starts with a question that sounds almost too simple to matter. Was the face put together correctly? Chapter 2. The Symmetry Test Picture: Two Faces. both reasonably proportioned, both healthy looking at a glance. The only difference is that one is slightly, almost imperceptibly, more symmetrical than the other, the eyes a fraction more level, the two sides of the jaw a fraction more matched. Ask a room full of people across dozens of cultures which face they find more attractive, and the more symmetrical one wins. Not by a landslide, but consistently, reliably, and this is the part that matters for a reason that has nothing to do with aesthetics. Starting in the early 1990s, psychologists Randy Thornhill and Stephen Gangestad, working out of the University of New Mexico, built a research program around a concept called fluctuating asymmetry. The idea is simple. A human body is built from a blueprint that's symmetrical by design: two eyes, two ears, a jaw meant to line up evenly on both sides. In a perfect world with a perfect environment, every body would come out matching, left to right. But nothing grows in a perfect environment. Parasites, malnutrition, disease, genetic mutation, physical stress during childhood, all of it introduces tiny errors into that left-right blueprint. The body absorbs those errors unevenly, and the result shows up as small asymmetries, one ear a little higher, one side of the face a little wider. Thornhill and Gangestad's argument was that facial and bodily symmetry isn't just a random cosmetic trait. It's a visible record of how much developmental interference a person survived on the way to adulthood. In other words, symmetry is a receipt. It shows the math of every disease dodged, every food shortage survived, every parasite the immune system successfully fought off during the years when the skeleton was still being built. A highly symmetrical adult is, statistically, an adult who had a genome robust enough and an early environment kind enough to come out of childhood close to blueprint. For a hunter-gatherer scanning a potential mate with no access to medical records, no ability to run a blood test, no way to check anyone's disease history, a symmetrical face was one of the only pieces of hard data available. It was a free, visible signal of a hidden variable: does this person's body handle stress well? Now, pause on that for a second, because this is where a lot of pop science explanations get sloppy. Later research, some of it done by Gangestad and Thornhill themselves, found the effect is real but modest, small in raw statistical terms, easy to overstate. Nobody is claiming ancient humans were running mental calipers on every face they saw. This wasn't a conscious checklist. It operated below awareness, more like a preference than an audit. But preference is exactly the mechanism evolution needed. It didn't require ancestors to understand why symmetry mattered. It only required them to feel a small, automatic pull toward it, repeated across millions of mating decisions over hundreds of thousands of years, until that small pull became a permanent feature of the species' taste. So, skull shape signals temperament. Symmetry signals developmental resilience. But there's a third signal, one written not on the face at all, but on the body, in a ratio so specific it can be reduced to a single number. And the story of how researchers found that number starts with a controversy that split an entire field of psychology in half. Chapter 3, The Zero. 7 number. In 1993, a psychologist named Devendra Singh, working at the University of Texas at Austin, published a paper that would go on to become one of the most cited and most argued over studies in the history of evolutionary psychology. Singh's question was narrow and specific. Does the ratio between waist size and hip size predict how attractive a woman's body is rated to be, independent of overall body weight? To test it, he built sets of simple line drawings, bodies varying in weight category, but also varying in waist-to-hip ratio, from a wide 1, 0 down to a narrow 0, 7. Then he had participants across different cultures rank them. The result, replicated across Singh's own follow-up studies through the 1990s, was strikingly consistent. Within every weight category, underweight, normal, overweight, the figure with a waist-to-hip ratio around 0, 7 was rated most attractive, most healthy, and most fertile. Singh's explanation tied straight back to biology. Before puberty, boys and girls' waist-to-hip ratios sit at roughly the same number, close to 1. 0. At puberty, estrogen redistributes fat toward the hips and thighs in females, and a healthy, reproductively mature woman's ratio drops toward that 0. 7 mark. The ratio rises again after menopause. and it's disrupted by conditions linked to reduced fertility. So on Singh's theory, the eye wasn't responding to a beauty standard invented by any culture. It was responding to a rough, visible proxy for reproductive stage and hormonal health. Information that once again would have been otherwise invisible to a hunter-gatherer with no other way to check. The paper made Singh one of the most famous names in evolutionary psychology almost overnight, and it also made him a target. In 1998, researchers Lawrence Tassinari and Christy Hansen ran a critical test of Singh's methodology and reported a much weaker relationship between waist-to-hip ratio and attractiveness than Singh had claimed, reigniting a debate that's still, in some corners of the field, not fully settled. Singh and a colleague fired back with new evidence using more realistic computer-manipulated photographs instead of line drawings, and found the preference for a ratio around 0.7 held up even after statistically controlling for perceived weight. And more recent work has complicated the picture further, in an interesting direction. A 2024 study published in Scientific Reports found that what people are actually responding to might not be the ratio itself, but something researchers called curviness, a broader measure of the difference between waist and hip width that correlates with, but isn't identical to, Singh's original number. On this account, the 0.7 ratio isn't magic. It's a rough marker that happens to track a deeper, more visually intuitive signal, a pronounced curve from waist to hip, full stop. There's a second wrinkle, and it's one that should make everyone suspicious of any claim that a single number is a universal law of human desire. In 1999, researchers Adam Wetzman and Frank Marlowe studied the Hadza, a hunter-gatherer population in Tanzania, one of the closest living approximations to the kind of subsistence lifestyle most of human evolutionary history unfolded under. And the Hadza didn't prefer a 0.7 ratio at all. They preferred higher ratios, and their attractiveness ratings tracked body weight more than shape. Wetzman and Marlowe's explanation was blunt. In an environment where the real, constant threat is starvation, visible fat reserves are the more urgent signal of health and survivability. The ratio doesn't matter if there's nothing on the body to distribute in the first place. So here's the uncomfortable, more accurate version of the story than the version that usually gets repeated. There's no single, universal number wired into the species. What's universal is the underlying question the eye is trying to answer. Does this body show signs of health, fertility, and enough stored resources to survive what's coming? And the specific visual answer to that question depends entirely on what kind of environment surviving what's coming actually means. Waist to hip ratio was never the point. It was one culture's dialect for a much older, much simpler sentence: can this body make it through a hard season? That's the biology, the parts of attraction humans didn't choose, inherited from selection pressures running for millions of years before anyone alive today was born. But there's a second half of this story that isn't about biology at all. It's about paint. And it starts in a cave on the southern tip of Africa, 100,000 years before anyone would call it art. Chapter 4. The first makeup kit in 2008. On the southern Cape Coast of South Africa, an archaeologist named Christopher Henshilwood, working out of the University of the Witwatersrand and the University of Bergen, was excavating a modest, cramped rock shelter called Blombos Cave when his team found something that didn't fit the existing timeline of human behavior at all. 2 abalone shells, tucked into roughly 100,000-year-old sediment, still holding the dried residue of a deliberately mixed substance, ochre, a red and yellow iron oxide pigment, ground down, combined with charcoal, animal fat, and crushed bone, and stored for later use. Alongside the shells, a quartzite grinding stone, a hammer stone, and bone tools clearly used to work the mixture into a fine, spreadable powder. It was, in plain terms, the oldest known paint-making toolkit on Earth, 100,000 years old, assembled with enough foresight to mix, store, and preserve pigment for future use rather than a single spontaneous act. Henshilwood's team went further in later excavations, uncovering ochre chunks from the same cave engraved with deliberate crosshatched and geometric patterns, some dated to roughly 77,000 years ago, others pushing further back toward the 100,000-year mark. And in the same strata, dozens of small marine shells, each one deliberately perforated, worn smooth around the hole in a pattern consistent with being strung and worn against skin or clothing for extended periods. Personal ornaments. Beads now. Pause and sit with what that actually means. 100,000 years ago, deep in the Middle Stone Age, tens of thousands of years before agriculture, before pottery, before almost anything modern humans would recognize as civilization. Someone in a cave on the coast of Africa was grinding red pigment into powder, mixing it with fat to make it spreadable, and stringing shells into necklaces. None of that keeps anyone warm. None of it helps hunt, fish, or build shelter. Ochre and shell beads solve exactly 0 survival problems on their own, which means they were solving a social one. Henshilwood himself has argued that ochre use at this scale represents the ability to source, combine, and store substances for what he calls the enhancement of social practices. And most archaeologists studying the site read body decoration as an early physical form of communication. A red ochred body, a strand of shell beads worn against the collarbone, these were signals, visible from a distance, broadcasting something about the wearer before a single word was exchanged. Group membership, status, health, since decorating a body implies the free time and resources to do something beyond bare survival. And very likely, desirability. Here's the pattern interrupt worth sitting with for a second. Everything covered so far, the softened skull, the symmetrical face. The waist-to-hip ratio was written into the body by genetics and childhood development, completely outside anyone's control. Nobody chooses their bone structure. But ochre and shell beads are the opposite. They're the first evidence anywhere in the archaeological record of humans taking the raw biological signal and starting to edit it, enhancing it, advertising it. The moment humans started deliberately marking their bodies to be more noticed, more desired, more identifiable as high status, that's the moment attraction stopped being purely a biological fact and became, at least partly, a performance. And once attraction became something that could be performed instead of just inherited, an entirely new kind of arms race became possible. Because if beauty can be built instead of only born, the next question becomes obvious. Who got to build the most of it, and why did some ancient humans have so much more of it than others? Chapter 5. The Beauty Gap. Here's a scene from roughly 30,000 years ago, somewhere in what's now the Czech Republic, at a site called Dolní Věstonice. Archaeologists excavating burials there over the 20th century found something unusual. Graves with a wildly uneven distribution of decoration. Some bodies were laid to rest with almost nothing. Others were covered, head to foot, in thousands of painstakingly carved ivory and bone beads, some sites showing evidence of headdresses and elaborate personal ornamentation involving thousands of individual pieces, each one requiring real time and skill to produce. That unevenness is the whole story in miniature. If ochre and beads were purely about signaling health or fertility, traits that are roughly randomly distributed across any population, decoration should be roughly evenly spread too. It isn't. It clusters. Some individuals in the ancient record are buried practically bare. Others are buried like royalty. And the widening gap between those two groups tracks something else entirely: the amount of spare time, skilled labor, and trade network access a person's family or group could command. This is where attraction stops being a purely biological story and starts becoming an economic one. A single shell bead, ground and polished by hand with stone tools, could take real time to make, sometimes hours per bead. A necklace of dozens or hundreds of beads represents dozens or hundreds of hours of skilled labor, either the wearer's own or labor they could command from someone else. In a world with no currency, no banks, no visible bank balance, a body covered in beads was, in the most literal sense, a body covered in visible proof of accumulated wealth and social capital. Which means, by the time humans were burying their dead with elaborate ornamentation 30,000 years ago, attraction had already split into two separate signals running in parallel. One layer, the older layer, was almost entirely involuntary. Bone structure, symmetry, body proportion, all inherited and largely outside anyone's control. The second layer was constructed, ownable, and unequal. How much of a group's collective effort could be converted into decorating one particular body? And that second layer didn't just decorate the existing biological signal. It started to compete with it, because a person with an average face and an exceptional necklace was now sending a message that had nothing to do with their bone structure at all. They were advertising resources, connections, and status. In a species that had already started favoring cooperative, socially tolerant partners back in Chapter 1. The ability to demonstrate access to a wide, generous social network might have mattered just as much as any inherited feature on the face. So two entirely different filtering systems were now running simultaneously in every mate choice a Stone Age human made. One asked, is this body well-built, healthy, developmentally sound? The other asked, is this person or this person's family or this person's group capable of generating and sharing resources? And once both systems were live at the same time, something almost inevitable happened next. They started to blend into each other until it became difficult to tell where biology stopped and status began. Chapter 6. The blending. By the time behaviorally modern humans were spreading across Europe and Asia, somewhere between 50 and 20,000 years ago, the archaeological record shows something that looks less like two separate signals and more like a single, tangled one. Consider ochre again, but now applied not just to skin, but to burial contexts across multiple continents, in patterns that suggest ritual meaning layered on top of decoration. Consider the famous so-called Venus figurines, small carved statuettes found across a huge swath of Ice Age Europe, from France to Russia, most dated between roughly 30,000 and 22,000 years ago. These figures, carved from ivory, stone, or fired clay, consistently exaggerate certain features: wide hips, pronounced abdomens, prominent breasts, while faces are frequently minimized or left blank entirely. Archaeologists still debate their exact meaning, but one widely discussed interpretation, advanced by researchers including Leroy McDermott, treats them as evidence that Ice Age humans were encoding fertility and body fat signals. The same signals underlying the waist to hip research from Chapter 3 directly into portable art, tens of thousands of years before Devendra Singh ever put a number on the phenomenon. If that reading holds, it means Ice Age humans weren't just unconsciously responding to fertility signals in real bodies walking past them. They were consciously, deliberately reproducing those signals in carved objects, handcrafted, portable, ownable versions of the exact biological cues natural selection had spent millions of years building into human perception. Which means the constructed signal, the artifact, the effort, the craftsmanship, had started to represent the biological signal rather than compete with it. That blending shows up again in the evidence for early clothing and adornment working together. Sewing needles made from bone, found at sites dating back roughly 40,000 years, show that clothing had shifted from a survival necessity into something that could be tailored, fitted, and, combined with dye, decoration, and ochre, used to accentuate exactly the body proportions the biological system was already primed to respond to. A well-fitted garment could exaggerate a waist-to-hip contrast. Careful hairstyling and pigment could emphasize facial symmetry. None of that required understanding fluctuating asymmetry or hormonal biology in any conscious sense. It only required generations of trial and error, noticing, however unconsciously, what drew the eye and repeating it. By this point in the timeline, asking was attraction biological or cultural stops being a question with a clean answer. The honest version is messier. Culture had learned to speak biology's language fluently enough that the two became almost impossible to separate. A carved fertility figure wasn't replacing an evolved preference. It was translating it into a new medium. A shell necklace wasn't replacing status signaling. It was compressing thousands of hours of social capital into something that could be worn on a single body, in a single glance, which leads to the turn this video has been building toward. Because everything so far has assumed the human range of what counted as attractive was more or less fixed. It wasn't. And the sharpest evidence for that comes from an entirely different species of human, one whose genes are still sitting inside most people alive on Earth today. Chapter 7. The Neanderthal Question for most of the 20th century. The default assumption about Neanderthals was that they were a separate, unappealing evolutionary dead end, a heavier-browed, stockier cousin species that modern humans either outcompeted or ignored. Genetic evidence gathered since the mapping of the Neanderthal genome, first published by a team led by Svante Pääbo at the Max Planck Institute for Evolutionary Anthropology in 2010, blew that assumption apart completely. The Neanderthal genome, extracted from bone fragments found across multiple European sites and sequenced against thousands of modern human genomes, revealed that most people of non-African ancestry alive today carry somewhere between 1 and 2% Neanderthal DNA. That number isn't a rounding error or a fluke of ancient contamination. It's the direct genetic signature of repeated interbreeding between Homo sapiens and Neanderthals, almost certainly concentrated in the tens of thousands of years after modern humans expanded out of Africa and encountered Neanderthal populations already established across Europe and Western Asia. Sit with the implication of that for a second, because it cuts directly against the framing this entire video has used so far. Neanderthals had heavier brow ridges, more robust builds, and different facial proportions than the modern humans they encountered. Precisely the kind of features Chapter 1 argued had already been selected against, millennia earlier, in the softening of the Homo sapiens face. And yet, interbreeding happened, repeatedly, successfully enough to leave a permanent genetic mark on almost the entire non-African human population alive today. That doesn't mean the biological preferences described earlier in this video were wrong. It means they were never absolute. A general evolved pull toward softer, more symmetrical, higher status signaling partners is a statistical tendency across millions of individual choices, not a hard rule enforced on every single pairing. Real attraction, even deep in the Ice Age, was messier, more circumstantial, and more individually variable than any clean scientific model can fully capture. Proximity mattered. Social context mattered. What counted as a viable, appealing partner in one small, isolated population on one particular frozen tundra 38,000 years ago was shaped by whoever was actually there to choose from, not by some perfect, universal ideal floating outside of history, which is really the honest closing thought hiding underneath everything covered in this video. Every signal described here, the softened skull, the symmetrical face, the waist-to-hip proportion, the ochre, the beads, the carved figurines, evolved not because any of them are objectively, universally beautiful in some abstract sense, but because each one used to answer a real, urgent, life-or-death question. Is this a safe bet? The zoom-out none of those ancient questions have gone away. They've just gone quiet. Nobody scrolling a dating app today is consciously thinking about fluctuating asymmetry, or testosterone-driven brow ridge reduction, or hip-to-waist proportions as a fertility proxy. Nobody's reaching for a specific shade of lip color and thinking about 100,000-year-old ochre workshops on the South African coast. And yet the instincts underneath all of it are running exactly the same ancient software they always were, just executing it on interfaces built by evolution for a world that no longer exists. Symmetrical faces still read as healthier, even in an era of universal antibiotics and modern medicine that has mostly neutralized the disease pressures symmetry was originally tracking. A confident, socially fluent presence still reads as more attractive than raw physical features alone, an echo of that ancient 2-million-year drift toward calmer, more cooperative faces. And decoration, makeup, styled hair, curated clothing, filtered photographs is still, in the most literal historical sense, exactly what it was in that cave in South Africa 100,000 years ago. An attempt to take a biological starting point and edit it, enhance it, make the invisible signal impossible to miss. The instinct is prehistoric. Only the tools changed.